In this video for Math 98, we will be doing examples from homework number 6, covering sections 13.4, which introduces the idea of the logarithm. These are like problems 6 through 15 on this homework assignment. Let's take a look at the exponential function, y equals 3 to the x. I'm going to graph it, and I'm just going to graph it by picking a few points. Okay, let's start with an easy value for x, 0. If I plug in 0 into this, I get 3 to the 0, which equals 1. So I'll plot that point, 0, 1. Let's take a positive number like 1. Plug that in here. That'd be 3 to the first. So that's just 3. So 1 would give me 3. Okay. And let's take a number 2. 2 would be 3 squared. If I plug that in here, that will give me 9. So 2 will be 9. I'll just draw it way up here, okay, to give us an idea. Let's choose some negative numbers for input, like negative 1. 3 to the minus 1 is 1/3. So that's going to be maybe something about right here. And let's try minus 2. 3 to the minus 2 is 1/3 squared, which is 1/9. So again, that number would be maybe about right here. So if you were to draw this, looks like a curve that goes like this. And let's think about this for a minute. Certainly as x gets larger, 3 to the x is just going to get more and more large. But as x gets smaller, negative 1, negative 2, negative 3, x, this value will get smaller and closer to 0, but it never will quite reach there. Okay? So this kind of gives us an idea of what this function looks like. Is this function 1-to-1? Well, it certainly passes the horizontal line test. So the answer to that is yes. So let's try to find the inverse. Using the examples from the last section, I would say, okay, y equals 3 to the x. So that means x equals 3 to the y. Uh-oh. How do I solve this? Well, I don't know. I don't have an algebraic way, so algebra doesn't really help me here. So I need to define something new. And what we're going to define new is the idea of a logarithm. So here's the definition. The logarithmic function is the inverse of the exponential function f of x equals b to the x. The logarithmic function is written f inverse of x equals log base b of x, where x is a positive real number and b is greater than 0 and b is not equal to 1. Now, that is a mouthful. What exactly does this mean? Well, we have a function 3 to the x. The inverse function is written log base 3 to the x. So what exactly is a logarithm? A logarithm is an exponent. For example, if you are given the function 3 to the x, and I give you the input 2, it produces the output 3 squared, or 9. So I give you the exponent, you get the answer. For a logarithm, this is asking the question, what is the exponent that I raise this base 3 to get that value 9? What is the exponent that I raise 3 to get the value 9? The answer is 2. Another way to say that is, what is the power I raise 3 to get the value of 3? If you think about that, the answer is 1. Here, 3 raised to what power is 81? That's 4. So these answers for the logarithms are the exponent that you raise this to get that. 3 raised to what power equals 1/3? That's negative 1. 3 raised to what power equals 1? That's 0. So that is what is meant by a logarithm. It's the opposite of the exponential function. In the exponential function, you are given the exponent, you get the answer. In a logarithmic function, you are given the answer and you are asking for the exponent. Okay, so let's use this definition of logarithmic functions to write the inverse. G of x equals 5 to the x. According to my definition, right here, okay, The logarithmic function is the inverse of the exponential function b to the x. So my logarithm, I would write for my inverse, is log base what? 5 of x. Here I have k to the x equals log base pi of x. What's the inverse of that? Well, if you're given the logarithm, the inverse is the exponential. So, like if you look at the relationship here, it's pretty easy to see that the inverse here has to be pi raised to the x power. So that's a little bit about starting the logarithms. We want to, in this section, give some comfort to working with logarithms. So here's a rule. The logarithm is the exponent to which we raise a base to obtain a given number. If y equals b to the x, where b is a fixed positive number not equal to 1, then x is the logarithm base b of y. So we say that these two statements are equivalent. Y equals b to the x equals x log base b of y. So sometimes in doing logarithm problems, here's what I do. Log base 4 of 16. Set that equal to some variable. I'm just going to call it x. And then I would write this as 4 to the x power equals 16. Well, you remember how to do these problems. That just tells you that x equals 2. Here, I'm going to set this equal to something. This time I'll use y. I'm going to say log base 5 of 125 is asking 5 raised to what power equals 125. If you think about that for a moment, you'll see that the answer is 3. Here, 7 to what power equals 343. 343, if you take your calculator, okay, right here, you say, does 7 go into 343? Yes, it does once, twice, 3 times. So 7 times 1 equals 7 times 7 equals 49 times 7 equals 343. So this tells you that 7 to the x equals 7 cubed, so x equals 3. How about this one? 2 to the x equals 1/8. So hopefully that tells you that 2 to the x equals 2 to the minus 3, so x equals minus 3. So we really want you to be comfortable with this relationship between the logarithmic function and the exponential function. Can you go back between exponential notation and logarithmic notation? So let's look at a table problem similar to one you might find on WebAssign. Here, you're given a column that says exponential equation, and you're given a column that says logarithmic equation, and your idea is to convert from one to the other. So here, log base 2 of 8 equals 3 is the same as saying 2 to the third equals 8. Log base 3 of 27 is the same as what? 3 to the third power equals 27. Now let's see if we can go backwards. Notice log base 2 to the third power equals 8 gives me log base 2 of the answer equals 3. So here, log base, well, what's the base here? 10 of the answer, which is 10, equals the exponent, which is 1. And here, log base, what is the base here? Of 6 of the answer, which is 216, equals the exponent, which is 3. See if you can do this one. So I have a logarithmic equation. I'm going to write it as an exponential. I'm going to take the base, which is 9, raised to the exponent, gives me the answer, which is 181. There are numerous problems like this on WebAssign. Let's see if we can just do some of these. I'm going to write these logarithmic equations as exponentials. So again, this is my base, this is my exponent, and this is my answer. This one, 10 to the first, equals 10. This one, 3 to the third, equals 27. And this one, 10 to the 0, equals 1. How about writing exponentials as logarithms? So this is going to be log base 2 that's my base. And what is my answer is 16. What is my exponent? It's 4. Log base 2, again, of my answer, which is 2. My exponent is 1. Log base 2, again, of my answer, which is 1. My exponent is 0. Log base 10 of my answer, which is 100. My exponent is 2. So be very familiar with this relationship between logarithms and exponential equations. Log base 10 is called the common logarithm, and it's written sometimes just log of x. If you notice on your calculator, there is a button that says log. That in your calculator means log base 10. So I can use my calculator to help me find some problems. So let's try this, log 10. So I'm just going to hit log and then put in the answer 10. So that gives me the exponent 1. Why does that make sense? Well, remember this means log base 10 of 10. And I'm asking what power do I raise 10 to get the answer 10? And that's 1. Let's look at another one. Log 100. Log 100, if I do that on my calculator, gives me the answer 2. So that's log base 10 of 100. And what power do I raise 10 to get 100? That's 2. But not everything is a power of 10. These two are a power of 10. You could have done these in your head without the calculator. You can't do this one, log 51, without the calculator. So let's see what the calculator says here. I'll do log 51. Log 51 gives me approximately 1.707. So I'm going to write down this is approximately 1.707. Now, what does that mean? That means 10 to the 1.707 is approximately 51. Now, we'll check that in a minute, but let's think about why this makes sense. You know that 10 to the first equals 10, and 10 to the second equals 100. So what power would I raise 10 to get an answer of 51? Well, 51 is in between 10 and 100, so it makes sense that this exponent would be in between 1 and 2. So if I take my calculator and I just take 10 and I raise it to the 1.707, I won't get exactly 51, but I get something pretty darn close to it. So this is what is meant by a logarithm. Again, this is the power that I raised this to get that. And this was an irrational number. I can't write it down exactly, but I can get something that makes sense. Let's try log 7. Log 7 gives me 0.845098. So this is approximately 0.845. Why does that make sense? Well, this says 10 to the 0.845 is approximately equal to 7. Well, you know 10 to the 0 equals 1, and 10 to the first equals 10. So again, because 7 is between 1 and 10, it makes sense that the exponent here would be between 0 and 1. Okay, let's see if we can do this one. And let's see if we can do this without our calculator. This is log base 10. And 0.2, that's 2 over 100. Okay? So, wow, that's interesting right there. Can we look at that and think about that right there? Let's take a look at what my calculator says. Log of 0.02 gives me minus 1.698 approximately, or 699. And try this one on your calculator just for fun. So that gives me minus 5.699. So those, again, are some good problems to work with this thing called the common logarithm. Common logarithm means log base 10. So if you don't see a base here, the assumption is that that's log base 10. Finally, let's take a look at this problem where not only are we going to write exponential and logarithmic equations, we're actually going to try to solve for something. So here I'm given the logarithmic equation, log base 2 of 128 equals x. That's equivalent to the exponential equation, 2 to the x equals 128. To solve this, let's see if we can write 128 as a power of 2. So I'm going to go over here and I'm going to take 128 and I'm going to divide by 2 once, twice, 3 times, 4 times, 5 times, 6 times, and finally 7 times. So this is 2 to the 7th. So that means that x equals 7 in this case. Let's look at this one. 10 to the 2nd equals 2 is my exponential equation. 10 to the 2nd equals x, is my exponential equation. And that's pretty easy to solve. That's just x equals 100. Here, x to the 5th equals 32 is equivalent to log base. Well, what's my base here? My base is x. What's my answer? 32. What's my exponent? 5. X to the 5th equals 32. If you take the 5th root of each side, that will give you x equals 2. 10 to the x equals 20 tells you log base 10 of 20 equals x. Now, I can't figure this out, but I do have log base 10 here, so I can use my calculator and say log 20, and this gives me approximately 1.301. Log base 10 of 40 equals x is the same as the exponential function 10 to the x equals 40. Again, because I'm given log base 10 here, I can write down log base 10 of 40, and that gives me approximately the answer 1.602. Now, here, what is the logarithmic equation? That's log base. What's the base here? The base is 10. What's the answer? X. What's the exponent? Negative 3. So this was given to you, x equals 10 to the minus 3. So that's pretty easy. That's going to be 0.001 for my answer. One more problem. Let's just write these as exponential functions and then solve. So writing this as an exponential function, this is 9 squared equals x. Pretty easy to solve. That's x equals 81. How about this one? 5 to the x equals 5. Pretty easy to solve. That's x equals 1. 10 to the x equals 0.001. And that, if you think about this for a little while, is x equals minus 3. Why don't you try these? What would this one be? 10 to the 0 equals x. 10 to the 0, of course, is 1, so x equals 1. How about this one? X cubed equals 125, so x equals 5. And finally, this one, a to the first equals x. That's an a, looks like a 9. A to the first equals x. So here, x equals a. I hope you have found this video useful.